Hi there and welcome back. We will continue with this hematology presentation as it relates to individual life underwriting. And in this video presentation, we will focus on one of the unique aspects of hematology, and that would be the composition and formation of blood. For those of you who have been doing this individual life underwriting for many years, say 20 plus years, recall how we used to look at the applicant or the insured who would say that he has hepatitis C. We would say, no, we cannot take it. It's an outright decline 20 years ago, right? Then with the research and development and various tools, we started to realize that those with hepatitis C, with proper treatment, diagnosis, follow-up, so on and so forth, can live longer. So we started to see the improvement, the trend of survival of those who have history of hepatitis C. And we started slowly and gradually taking those cases based on individual considerations. And the things have changed where we were 20 years ago and where we are now. That is hepatitis C. Take a pause and think what we are currently doing. Maybe the kind of like the similar trend, although it is in the beginning phase, when it comes to someone with HIV positive. It used to be an outright decline. Now, although very few companies and they go case by case, but they have at least started to take a look at those who have HIV positive, and because of the research and the treatment and the options available, those with HIV positive are living longer. So every company is scratching their head and they are trying to think about, okay, can we capture, can we explore this market on case-by-case basis? Although that is the beginning, but you never know how we may be underwriting those with HIV positive, given up ongoing research and the treatment that may improve the mortality expectations, right? And who knows what will happen after 20 years. But take a pause and think about hepatitis C and HIV positive. And then now think about the composition and formation of blood. We can do heart transplant, we can do liver transplant. We are able to now look at from a different perspective the hepatitis C and or someone with HIV positive. But as we speak, as of today, we cannot create artificial blood. Okay, so what are the composition and formation of blood? What is so unique that even as of today we cannot create artificial blood? So let's move on to the next slide and we will see in detail the composition and the formation of blood. If you recall, I did touch base that about the blood, that when we look at the blood we think that it's all red, but that's not true. That's only 45% of the cells that we have in the blood. The 55% is all plasma. So blood, when we say it's 55% plasma and 45% cells. And plasma, of course, we know it includes water, salts, hormones, proteins, sugars, vitamins, all those ingredients. In life underwriting, our focus when we talk about CBCs, we are looking at the cells suspended in plasma, and they are red blood cells or the erythrocytes, white blood cells or the leukocytes, and the thrombocytes or the platelets. So those are the three key players that we want to pay attention to when it comes to the hematology. So why don't we take one at a time and try to dive a little deep into each of these unique cells that we have in the blood. So First and foremost, let's talk about the red blood cells. Red blood cells are very unique. They are like, when you have a cold and you take a cough drop, that's the shape of red blood cells. They have a biconcave shape and there is no nucleus. So you cannot divide, there is no DNA that you cannot divide the RBC or the red blood cells to have more red blood cells. It has to be created, it has to be made by the bone marrow. Okay? But the uniqueness about the RBC is this, that with no nucleus, they are flexible. They can go anywhere, even the tiniest capillaries. Remember in one of the previous video presentation, we were looking at the length of the capillaries. When you add up the arteries and veins and capillaries, it can go around the globe 2.5 times. So, without the nucleus and being so flexible that the RBC can reach out even to the tiniest capillaries, because remember, RBC is what? Has a unique protein, and that is called hemoglobin, and oxygen is needed everywhere in our body. So it has to reach out everywhere. So there is no nucleus, they are so flexible, they can reach out even the tiniest capillary that we have in our body. And because the RBC contains the hemoglobin, and the primary purpose or the function of hemoglobin is to carry the oxygen everywhere throughout the body in each and every tissue that we have. Okay. It originates in the bone marrow, and the kidney is the one that drives or kind of regulates, hey, I need more oxygen. So the hormone called erythropoietin is secreted by the kidney, and that stimulates the production of RBC. The average life of RBC is about 4 months. It circulates in the bloodstream, and then the macrophage will destroy in the spleen, liver, and it will move on. So let's move on to the next slide. So what happens? The macrophage will break down the hemoglobin into the heme and protein, and here you go, the bilirubin comes into the picture. How? Because the heme releases the iron and decomposes into the dark green pigment called bilirubin. The iron hemoglobin is reused to form the new red cells or stored in the spleen, liver, or bone marrow. Bilirubin, we know how we get the brown color to the stool, so I'm not going to go into that details. But what you want to pay attention to is the fact that there are about 2 to 10 million red cells that are destroyed each second, but because they are constantly being replaced, the number of circulating cells that remains constant is in the range of 4.5 to 6 million. Okay, so let's move on to the next slide, and that's all about the RBC for now. Moving forward, white blood cells. White blood cells are our immune system, built-in immune system, our defense mechanism. So they are like the soldiers. If there is any external attack on our body, they come to defend and familiarize the normal range and the different types. And I would say a couple of things here, that the neutrophil and the lymphocytes, they dominate. Half to almost two-thirds of the neutrophils and the lymphocytes, they dominate. They all work together. The remainder of the categories or the sub-classifications are very small in the percentage. Let's move on to the next slides, and we will touch base about the platelets or the thrombocytes. Actually speaking, the platelets or the thrombocytes, although in the one of the previous sessions we said cyte means cell, thrombo is platelet, they are technically, they are not cells, but they are the breakdown of megakaryocytes. So megakaryocyte is a big cell, and when you break down that megakaryocyte into 4, 5, 6 pieces, then it turns into what we call thrombocytes or the platelets. They are formed in the red bone marrow from the giant megakaryocytes. The normal range, familiarize yourself with the normal range. It may differ depending upon what the doctor prefers and what you see in the medical records that you have ordered to better underwrite the individual. 1/3 remain in the spleen, the 2/3 are in the circulation. The key aspect or the key function when it comes to platelets that should come in your mind is the coagulation. So they are there, and we will have a separate presentation on the process of coagulation, but suffice to say here that they come to rescue and prevent the bleeding that may happen due to the injury or things like that. But we'll cover that in a separate session. And the general lifespan is about 7.5 days. So these are the red blood cells or the erythrocytes, the white blood cells or the leukocytes or the thrombocytes or the platelets are the three players that when we look at the composition and formation of the blood, and they are so unique that even today as we speak we cannot create artificial blood. So those are the things that we want to pay special attention to. So we will take a break and then we'll come back and we'll look into the different aspects of hematology as we move on in this presentation series. See you soon. Take care. Bye now.